I'm very glad to introduce my teacher, Professor Rajeev Sangal. Professor Rajeev Sangal graduated from IIT Kanpur, and then he did his post-graduation and PhD from University of Pennsylvania with Professor Arvind Joshi. He was, after doing his PhD, he returned back to India and worked in IIT Kanpur for almost 15 years, during which he showed the relevance of Panini's grammar for natural language processing. So during this time when he was at IIT Kanpur, he developed a Paninian framework for computation for Indian languages. With this framework, he developed a parser for Telugu and also extended Panini's grammar, grammatical framework for even English language. During this period, he also was, he took lead with, along with Professor Vinit Chaitanya in building Anusarakas, the language accessors among various Indian languages. And then in 2002, after, I think in 1998, he joined IIIT Hyderabad as a director. He joined in 2002, and he actually contributed a lot in the development or bringing up this university, IIIT, by several innovations. And one of the innovation was he did away with the normal department structures, and he built this university which centered around several research departments or research centers. And thus, a student who joins this university right at the beginning gets a feel for research, and this research is not just research for research sake, but research which is useful for the society, and he sees to it that this research leads to the development. Later on, he was also the founding director of IIT BHU, and now he is again returned back to IIT Hyderabad. I should also mention that he actually is the leader of NLP, Natural Language Processing community in India. He started the most important conference on natural language processing by name ICON in India. And of course, he is a leader, as I said, for all the NLP community in India. And the basic strength of him, I would say, is he is using Paninian grammar formalism, insights from Indian Grammatical Tradition for natural language processing. No wonder he was awarded Sanskrit Mitra Puraskar a few years back. So I welcome Professor Sangal, and he will be speaking on Indian Grammatical Tradition, how it can help build modern language technology.
Thank you, Ambaji. I can see Professor Gerard Huet, Dr. Pawan Goel. I'm not able to recognize everybody from the small picture that is coming here, but good morning to all of you. So I'll just share my presentation. 1 minute. Okay. I think I must mention before I start that Dr. Vinit Chaitanya, my senior colleague, I worked with him right from beginning at IIT Kanpur, 84 onwards, and then later on at Hyderabad. So he deserves the major claim for connecting me to Sanskrit and then his insights and working with Sanskrit Pandits, scholars, that helped in the development of computational Paninian grammar. So today's topic is how we can use our traditional knowledge to build modern language technology. So before we talk of building modern technology, let us see where things stand today. And in my outline, I'll first talk about this, then talk of technology development, what are the major applications followed by that technology development, then role of Indian grammatical tradition, and so on. So I have chosen one major application. This is speech to speech machine translation, SSMT. And first question is about translation itself. Why language translation, whether text or speech? So there is an acute need more than ever before in India. Education has expanded. Very large number of students are entering higher education who are actually not proficient in English, where English is currently the medium of instruction in higher education almost all the places. And they find that the books and materials in Indian languages are largely missing. So this social change that has occurred in India, where underprivileged background, people from rural areas, people from underprivileged backgrounds in cities, etc., have entered education, and they find that the material in their own language is largely missing. On the other hand, the devices, electronic devices, are in the hands of the common man. And it is not now just students, but common people have these devices. They they use it for accessing information on the net, and there are all kinds of material which is available, all kinds of useful material is available, and they find that they cannot access this material because it is not in their own language. So this is the need scenario for language translation. Now if we come to speech, there is also a large amount of spoken material available in English and of course many other languages, but very small amount of material in Indian languages, of course, other than Indian films. So if you talk of educational material, courseware, video lectures, NPTEL, MOOC lectures, also TED lectures, so these are available in English and they are not available in Indian languages. So this is the state. So on one hand there is desire, people want to access material and it is there and they have the devices, and what is missing actually is language. So material is not in the language they know. So therefore need for translation, both text and speech, has become a major need which has now been felt all over the country. Language translation. Now let's look at the problem very quickly. Somebody would say, oh well, for speech to speech translation, break up the problem into parts. First you transcribe the spoken English. Let's say you want to go from English to Hindi, then transcribe the spoken English, or English to Bangla, then you have to but first in any case you transcribe in English, and for that you require speech recognition and dictation. Then you display that material as subtitles. It is plain transcription, and for this there is standard technology available. And then you translate from text to text, English to Hindi. And if you want to get all other Indian languages, so you go from English to one Indian language, and then from one Indian language to all other Indian languages. So quality of translation. Yes. Can you hear me? Yeah.
Yes, sir.
Yes. Can you hear me?
Yes, sir. Yes, sir. We can hear you.
Okay. Okay. So then you translate, or suddenly X comes, a very large X. 1 minute. Hello? Yeah, the echo is okay. So you translate from then one Indian language to all other Indian languages because the languages are closer, they have a similar structure, even though not all the same, there are major similarities. And then finally, speech from text. So this is what comes to anybody's mind, and you can see the state of technology. Nowhere it is automatic, except the last step, and there it may be automatic, but the quality, if you want to bring in intonation, that's not easy. So semi-automatically means that it produces output with some errors, and frequently it is not considered as publishable quality. And people want a much higher quality, at least error-free and easy to understand translation. Okay. So what you do, you correct things with hand, you take the human input in correcting things. So you do manual post editing. In speech you do hand correcting the transcription, and in machine text to text you do manual post editing at both these steps, and that is where things are. So if you want to now solve this problem or help solve this problem substantially, then what do we need to do? Okay. So first thing we should realize that when we produce a text from speech, namely transcription, we have thrown away prosody, we have thrown away intonation, we have thrown away pauses, we have thrown away disfluencies, which is okay, but all these other useful information has also been thrown away, and that makes the translation task more difficult. And so first thing that would need to be done, we have to rethink our strategy. So instead of automatic speech recognition which produces text, we have to produce the rich text, a text which is marked with prosody. Okay. So we would want pauses, stresses, intonation, etc. Then when we do text to text translation, then if it has prosody and discourse information, if I may add, then this can be used. First of all, prosody can be used in input text, in parsing of the text, analysis of the text, and then when we do the transfer from source language to target language, then these stresses have to be transferred appropriately, because some of these stresses are part of linguistic structure. Sometimes they are given through pitch accent, and these things have to be transferred. And in addition, discourse processing becomes very important, and because intonation and prosody information is there, so we might as well use discourse information while producing translation. One of the practical things which people have found who are using machine for translation currently today for Indian languages, they say that it's a two-level translation. So somebody does post editing, so machine runs on the input. Let's say the translation is from Hindi to Bangla, then Hindi analysis is done text to text, and then Bangla is produced, and it is sentence by sentence translation, as we all know today. That is where technology stands. So on that sentence by sentence translation, the hand correction or post editing is done by people, and when it is given to second level, namely senior translators for vetting, they say no, this translation is no good. If you look at every sentence, you say no, this is a reasonable translation. Then what is missing? So what is missing is the continuity, coherence, discourse processing, etc. So this aspect today must be brought into translation, and if you have rich information about prosody, it should certainly be used. Of course, the final step is text to speech with prosody, and this is where you would like to put in intonation, etc., even pauses in the final output. So the technology that is needed, on one hand, it is not just a matter of stitching together automatic speech recognition with text-to-text machine translation and text-to-speech, but it is more than that. It is bringing in all this information that needs to be transferred from one stage to another. Okay. Now, in addition, even when you build a system, you are actually translating in domains, and in particular applications that are chosen are with the MOOC courses, educational material, and they come heavily loaded with domain knowledge or domain terminology. So even though we may want to build a general purpose system, it should be rapidly customizable. So this would be very important, and this customization would suddenly make it work much better for that particular domain. And as you build up these repositories for the domains, then in future when you come across a new request for translation in a given domain, these technical terminologies become available from beforehand. Okay, this is all what I have shown in the form of a diagram, and so we thought we would have three groups of institutions working on this. And here when we say speech technology, we don't mean just speech to text, but speech to rich text, and this means text, not just text to speech, but rich text to speech. Okay. And OCR has also been added because that can help convert images of text into actual digital material, text which can be processed by machines as characters and not just as images. Now if you look at the existing technology, there are three major approaches for text-to-text machine translation. One is a rule-based machine translation system. These make use of linguistic information heavily. Then there are statistical machine translation systems that use statistics. They typically are trained on annotated corpora. So you have not just plain text, but you have text with markup. Markup could be grammatical information, it could be some semantic information, it could be terminology. So it contains markup, and machine learns from such markup. And the third, which has become very popular these days, and there is much talk about it, is the neural machine translation. These turn out to be rather monolithic systems. They are not usually, at least currently, broken up into parts, and they go from source language text to output target language text. And there is what happens inside is not very clear. It's not understood well how machine has learned something. You only do some tinkering, keep doing tinkering. Whatever insights you have from linguistics or statistics, you try to guess and put something here in the neural system, and then train the machine again. And through this multi-layer neural system, the machine learns, and this also requires large amount of data. So one problem is that these have become monolithic systems, which means very hard to integrate them with one or two. Statistical actually and rule based are quite are reasonably well integrated today, perhaps not at theoretical level, but in practice many of these systems borrow from each other. In fact, the design of the system is more modular, not monolithic. So but when you go to neural, unfortunately it is, you don't understand what's happening, and also there is very little linkage with the other two. So this would be a challenge for people who work in this area, because I believe that monolithic systems are not going to last for very long, because we want all kinds of flexibility. And I mentioned, for example, domain customization. So if you have text in a given domain, then what would you do? Would you wait for text to collect, large amount of text to be collected for that particular domain before training your monolithic neural network MT system? So that raises a question. Modular systems, on the other hand, can train on much smaller amount of data because you are also trying to learn small parts because this system is modular. So for each module, learning component is small, and so therefore requirement of resources, particularly parallel text, is very large for neural machine translation systems. Now languages, if you look at Indian languages, most of the Indian languages are low resource languages. There are 22 officially recognized Indian languages, and in fact there are 250 odd mother tongues which are spoken by 10,000 or more people, and if you count all the languages together, they are of the order of 900 languages which are spoken in India. So if you want to build for all these languages, or even for the 22 official languages, even there, many of the languages, most of the languages are actually low resource languages. Hindi I would call as medium resource language, and maybe a couple of others will fall in that, and really there are no large resource languages for among Indian languages. Okay. You should also recognize that different approaches work well in different scenarios, both about domain, about terminology, about amount of resources needed, amount of annotated data required, etc. So it is prudent to take a hybrid approach where we will have all the three, and my own experience tells me that what we do here, linguistically based, linguistically informed systems, we as human beings get our insights from there, and even if when we are doing machine learning, we transfer those insights to these other systems. So the first part, linguistically informed or rule-based machine translation systems, are going to be the key for understanding and then building both linguistically informed systems as well as perhaps bringing in statistical components as part of that system, or building a neural system. So in any case, this is going to be and is already very important and is going to remain so in future. So the question now is, what is the role of Indian grammatical tradition, given that there is this large need and there is need for speech-to-speech machine translation, and that there are all these approaches which are available to us. So I sort of list a few tasks. These are certainly not exhaustive, but this will give you an idea of the kind of things we need to do today. And using the Indian grammatical tradition, Sanskrit insights of Sanskrit grammarians, as well as other smaller traditions, it will be very important to use those and bring that in building technology of the future. So I mentioned, developing of the framework itself, and the framework, basic insights and work of Panini is already very detailed. So then in that case, we need to apply that framework to other languages, for example, modern Indian languages. Then using technology to make Sanskrit texts more widely accessible amongst people, that would be another task which needs to be done. And now that there is such a good need has been felt for translation, this is the time to get on to the task and do serious work. As we say, kamar kas ke ab kaam karne ka samay hai, get ready to work hard. Sanskrit digital libraries, I don't need to underemphasize it, it's very important. Build various tools. Discourse analysis, and I've already mentioned the role that this can play today in translation. Then role of Indian grammatical tradition in building speech tools, speech engines, and then finally the impact of the tradition on education about language, and not just language, more than that. So I'll take up each one of them, and let me take the first one, computational Paninian grammar framework. And here there is an existing work which has been done on computational Paninian grammar, which has been applied to modern Indian languages. As part of that, tree banks have been built for modern Indian languages. That has led internationally, tree banks have been built for many languages of the world. This has led to the development of universal dependencies, and I feel that this development has taken place without too much understanding of insights from Indian grammatical tradition. Otherwise, these dependencies would have been more general. Currently, they are more technology based. What technology can produce, those kinds of dependencies have been incorporated as universal. On the other hand, if we have the insights of Indian grammatical tradition, we would have come to different conclusion, and we would have handled inadequacy of technology in a different way. And then why just tree banks or application of Indian grammatical tradition to Indian languages? Why not to English, French, German, Spanish, Portuguese, Chinese, Korean, Japanese? Why not? Why not to other languages? So this is a task which we can take up. So I'll very quickly take you through the idea of tree banks and Indian computational Paninian grammatical framework. Very quickly I'll just switch the slide. Okay, so I think I'm on the right slide. The same copy is there in two places, but I can't see the number, unfortunately, when you make it full screen. But kindly bear with the problem. So let's take this sentence. Ram chaku se सेब काटता है. Ram cuts the apple with a knife. Okay, and this is a sentence in Hindi, and this is the dependency tree. If you do Shabda Bodha, then this is what you get. Kaat is the kriya, dhatu, and Ram is karta, chaku or knife is the karan or instrument, and save or apple is the karma. So that is the tree you get. That's a tree you want, rather. So the question is now, how do you produce it? Sorry, I'll come to how to produce it a little later. 1 minute. Okay, let's go to another example. A relative clause in Hindi, which is actually correlatives. मेरा भाई जो दिल्ली में रहता है कल आ रहा है. Okay, so my brother, 1 minute, who lives in Delhi is coming tomorrow. Okay, so we all understand my brother is coming tomorrow, and who lives in Delhi is the relative clause. And how? So the question is, when you apply the Paninian framework for Hindi, then what would you do? So English has this relative pronoun, and in here Hindi is also using a relative pronoun jo. So who and jo, and Hindi also uses a correlative, which is optional, but most of the time it uses it. So jo wo. So वह कल आ रहा है. So another lexical item is introduced, lexical pronoun is introduced, and that would come as wo. Okay, and my brother. So that is what would be done. So this is what you can do. Sorry, this. On 1 minute. Can't see this. My screen has become, slide has become blank. It was visible earlier. Okay, so there is another one. I will try this one. 1 minute. For the same relative correlative, take another example. तुम ऐसा सुंदर घर बनाओ जैसा उनका है. You build such a beautiful house as is theirs. That's what it is saying. So you such build beautiful house build. You build such a beautiful house such that it is like theirs. Okay. So you notice again correlative, such that and such, and all Indian languages have this correlative. Dravidian languages don't use relative construction very much. They have rich set of participial constructions, but Hindi, Bangla, Marathi, Punjabi, Gujarati, all these languages use Odia, the Assamese, they all use this relative correlative construction. So now the question is, when you apply Paninian theory, then how would you represent it? So do Shabdabodha here, and in this the main sentence is Tum ghar banao, you build a house. Tum is you, build house. What type of house? Beautiful house. Tum sundar ghar banao. Okay. So you build a sundar house, and I'm sorry, what kind of beauty? As beautiful as theirs. Okay. So this aisa is your such that marker. It's acting like a relative correlative. And hai jaisa unka ghar hai, right? Hai is theirs. So this is a kind of construction you would get, keeping the Indian grammatical tradition in mind, and of course doing justice to language, in this case Hindi or whichever language we are looking at. And it turns out that this structure turns out to be common across Indian languages wherever there are relatives and correlatives. So this insight comes actually from Paninian grammar or Indian grammatical tradition, and this can be put into while analyzing modern languages, modern Indian languages. Another example, conjunct verb. So राम ने बहुत देर रवि की प्रतीक्षा की. Ram waited for Ravi for a long time. So English waited is the verb, and if you look at this here, waited, wait did. Pratiksha is actually not a verb, it's a noun. Okay, and it doesn't even have a verbal form. Of course you can make a verbal form, but otherwise this is the basic noun form, and this is the main verb. Or actually here, if you view the whole thing together as a actual verb, then this is a support verb. All the akanksha, or what the demands on other kinds of karta, karma, etc., these are determined not by ki, did, but they are determined from pratiksha. Okay, it's a light verb construction. Also many European languages have it. Indian languages use this extensively. Okay, so now the question is, what should we do? This maybe we'll skip the second example, we'll go to the first one, continue with the first one. So, but similar pratiksha kiya is prashna kiya, asked a question. So prashna is a noun, kiya is a support verb. So prashna kiya is the together thing is a verb. This is called the conjunct verb. Okay, and in prashna kiya, question, this is the conjunct verb. And Mohan ne Ravi se prashna kiya. Mohan asked Ravi a question. So Mohan asked, to Ravi, and Prashna Kiya is questioned. But the problem is, if you view this whole thing as a single verb, a single node, there are other problems. For example, you can say Mohan asked Ravi one question. If but one, when you are referring to, or two questions or one question. So this continues to behave as a noun. It can take modifiers. And what should we do? So here the answer is that you continue to maintain this as a separate noun and separate support verb do. So if you were to draw the figure, rather than writing Prashna Kiya, asked question or did question, this is what literally means, Kiya means do. Instead of keeping this as one node, you keep the verb as the main node, but bring Prashna down below as a noun. And it continues to have its, it can take modifiers. And again, one can, apply Panini's theory and do all this analysis properly. And this arc is called Prof, or something which is very close while assigning meaning. For example, while assigning Karaka relationships, these two have to be fused together. So the Karaka information comes from here, and that is used for then building the tree. So in the tree, we would show them as separate, but at the same time strongly linked. But because they are separate, this continues to behave as a noun, and it can take other modifiers, etc., like other nouns. Okay, so this I've just given you a couple of examples. I have many more and many very interesting examples, but I think or maybe we can take one more example. This is from Premchand's novel Farmer's Wife. 1 minute. Yeah. Farmer's wife did not like that bird. That bird did not appeal to farmer's wife. Okay. And Kisan is the farmer wife, and that bird did not appeal. And the author uses an idiomatic phrase to say did not appeal. Okay. And that idiomatic phrase, Futi aankh nahi suhati. Suhati means did not appeal, but the strength of this disappeal is given by Futi aankh. Even though I may be blinded, I can't see, right? Don't want to see. That sort of a thing it is trying to say. And the author uses this in the sentence. So this is an idiom, but it is behaving now like a verb. The whole idiom is like a verb. So what do we do? So you can say, well, this whole thing is like a verb. I've lost the cursor. 1 minute. It's a little struggle. Yeah, cursor has come back. So this whole idiom is acting like a verb, and it has various karakas, etc. So this is what is there. There is an error here. This R6 is between two nouns, not there. But anyway, K1, K2, this karta and karm. K1 is karta, K2 is karm. You do that, and this is the verb now. But the verb is a whole idiomatic phrase, meaning not appeal. So again, because this idiom is also not frozen, you can put in some additional things there. So we separate out the verbal part, suhati hai, not appeal, and the strength of disappeal, which is like a noun. So that noun together with this verb is separated out, and this and this again is linked with POF. So the advantage is that you retain, it's a semantic structure which also can take care of various syntactic phenomena that are occurring. Okay, grammatical, we are faithful to grammar as well as to semantics. Okay. So let me sort of stop here for this and go back to my example. So we were here when we came. So this was an example from actual tree bank. So there are tree banks that have been built, 50,000 word tree bank for Hindi and Urdu, and there are also slightly smaller tree banks built for another, I think, half a dozen languages: Telugu, Marathi, Bangla, etc. So these tree banks, first of all, give you practice. They give us practice in applying our theory to actual usage, actual language usage. And the other part is that the tree bank, full screen, yeah, I'll come to that, 1 minute. And so I go back, so I go to another thing, 1 minute, that how do we process these things? Now we'll make it full screen. 1 minute. 1 minute. So this is again from another transparency set of slides which are prepared by all work done earlier. I'll come back to the actual example. So Ram gives a toy to Mohan. Ram Mohan ko toy gives. Okay, that's the gloss. And taking inspiration from Panini almost directly, what he's doing for Ashtadhyayi, in Ashtadhyayi for Sanskrit. So we build a similar demand chart for Indian languages, in this case for Hindi. And this gives you the cursor disappears every time I go to a new slide. Okay, so this is Karta, says is mandatory. Vibhakti takes is Prathama Vibhakti or zero postposition for Hindi. Lexical type is noun. Source position is on the left of the verb typically. This is not hard but soft constraint. And the arc direction, this is a child of the verb. So if you have the verb they, give, and you take its default TAM, tense aspect modality or verbal vibhakti, then this will this gives you the grammatical constraints. Okay, so this is what is called as Karaka frame or Karak chart. One can also draw it in the form of a tree. So these are constraint trees. These are not actual trees, these are grammatical trees. They give us what to do. And process of parsing actually is applying this grammar to a given sentence and then coming up with a parse. So this is the basic thing which identifies, which gives details about what are the akanksha. And then of course verbal endings play a role. Panini has said is abhite and anabhite. So in Hindi, if you have a different, so this is taken as the default verbal vibhakti, but there are other forms. So this is what was deta hai, gives. But if you have past diya, past tense, Ram ne Mohan ko khilona diya, Ram gave Mohan toy. I'm sorry, this is some error here. And dena pada. Dena pada means had to give. Ram had to give a toy to Mohan. So each time this changes, this brings about change here in the vibhakti of the noun. In Hindi it is realized as postposition. In Dravidian languages this would be realized as case ending. And if you are actually applying Paninian grammar to English, this would appear as preposition as well as subject-object position, right? One of them. So this is the view that coming straight from what Panini did for Sanskrit. We are trying to do the same thing for modern Indian languages here. And once you apply it, then you transform the Karaka chart and vibhakti which was 0 earlier becomes ne. Why? Because earlier karta was abhite, so it was already said in the verb. Now when you change the verbal form, is no longer said, so it must be expressed by its vibhakti. So karta takes ne, and this is what happens here. So you do this transformation before actually applying it to the sentence. Okay, and this is done by looking at the verbal ending ya. This is a tense aspect modality label. So this is what you do, and you do that, and then you get the appropriate tree here. Okay, and when you do this, let's say for simple sentences for Hindi, then you might as well, this is where statistics can also be combined. You can do part of speech tagging. In this case, in actual parser that we have, which is running, it does morph analysis as well as does part of speech tagging to select which of the morph answers is to be taken, because morph runs on an individual word, while part of speech tagging takes into account the context in which the word occurs. So this is a statistical technique, and this is a linguistically informed and involved step, and we combine the results of the two. Okay, and then after that it's a linguistic process of loading the karak frame, transforming it, then finding candidates, then applying the constraint and solving it to give the final parse. Okay, so if you have the same sentence as before, this is what you would have. These are the arcs which are labeled with dependency arcs, which are labeled by the karaka labels here, and this is what is appears. So this is a possible graph. These are the possible edges, and notice that there are two karm here. Mohan can be karm as well as khilona or toy can be karm. So one of them will actually get selected. Okay, and this selection is done by integer programming, and when you select, let's say, khilona, then this only one K2 arc is left, only one arc is there obviously for karm, and Mohan is sampradhan, and so on. So this is from constraint graph, namely all possible arcs that are permitted by the karaka frame. We select now arc such that mandatory karakas are satisfied, optional karakas are there or may not be there, and most importantly the whole thing is a tree, which means every arc has an incoming node, and including the verb. So we create a dummy arc which says this is the root of the sentence, and the arc comes. So except for this dummy node which is created, this does not have a parent. Every other word or every other arc has a parent. Okay, here we are anyway chunking part this, and the parser will produce this output, and this of course this can be removed as the dummy root node, so the root is actually given. So this is what the parse tree is produced, and this is done using integer programming. Okay, integer programming constraints, and every arc becomes actually, every single arc is xijk. It stands for 1 or 0 depending on whether the arc is there. So let me not get into this, and this gets solved. Integer programming problem, we know how to solve it, and in this case it turns out that it runs quite fast, even though computationally it can be, it's more complex, but it gives us the power to do all this. And when you take complex sentence with more than one verb, so for example, phal khakar, having eaten, then you sort of do it in two phases, and phase one is where you are satisfying the local dependencies, which means dependencies for each of the verbs, and in phase two you find connections connecting the different verbs together. Okay, so that's the basic idea, and let me now go back to okay, where is the full screen. Okay, so we build a tree bank, so we work out a framework for our languages, inspired rather direct, almost direct application of the Indian grammatical tradition. Then you build tree banks, parsers, build parsers, and out of this can emerge universal dependencies for all languages of the world. And for that, one will have to apply this framework for other languages. So this is another task that is before the community, to apply it to modern Indian languages as well as to other languages of the world. Making Sanskrit text accessible, and this is where one can actually build machine translation systems from Sanskrit to Indian languages. For example, Ayurveda, this is a domain specific area, so one builds machine translation with domain terminology plugged in, and practitioners of Ayurveda, not all of them know Sanskrit today, they can access the original granthas, original shastras, and read that. Of course, when you look at scholarly work, which is to be studied by scholars or practitioners, experts, then you are frequently not satisfied by just translation. You want to read the text, original text, authentically. So that is where you can build Anusaraka or language accessor for Sanskrit, and this can be used for accessing Shastras. So this can also be used to read language texts, Ayurveda texts, or any other, darshanas. So people who do not know Sanskrit very well or do not know Sanskrit at all, even they will then be able to access the knowledge which is there in Sanskrit. Sanskrit digital libraries is important to build tools, particularly search tools, and search tools should be cross-lingual search. And to be able to do this, we will need cross-lingual dictionaries. Fortunately, word nets have been built for major Indian languages. I do not know whether one has been built for Sanskrit. Sanskrit has Amar Kosha in any case. So I believe Amar Kosha has been linked to the word nets for modern Indian languages. I'm not sure, but I think so. So these resources can be used for doing cross-lingual search. OCRs might be very important for digital libraries because much of the material is scanned, so it's in the form of images, and one should be able to convert that into text, then do search or translation or whatever. I come to discourse analysis, but I will speak very briefly on this because this will require a much larger, take time to do this. If you want to do good quality translation, then discourse information must also be used by systems, and in particular co-reference, then topic, focus, or what is called as centering. This is a psychological focus, and these are very important for coherence. So if you want to get successful, want to become successful in speech-to-speech machine translation, this will play a very important role. And Mimamsa, the area of Mimamsa, studies discourse, not just sentences but discourse, and connectives between discourse. So a type of relations between sentences. So they will have to be used. So people who are doing Mimamsa work, they can see what kind of need is coming from modern technology, and then they become the contributors and the builders of modern technology which is producing useful things for large numbers of people today. Speech tools, of course. So before you apply, your theories, or we apply our Indian grammatical theories for other languages, first apply to Sanskrit, gain an insight, and then see how it can, what role it can play. Finally, education. So India is, follows 3-language formula. So a child is supposed to learn 3 languages: Hindi, English, and the mother tongue or regional language. And also Constitution desires that child starts learning through mother tongue or through the regional language. And then later on these 2 other languages are added. This is a broad principle of 3-language formula. Not all states follow 3-language formula. Some states follow only 2-language formula. That's okay. So now in education, the goal of 3-language formula is so that people can converse with each other across the country. It brings national integration, etc. So this Indian grammatical contribute to this, where while the child is learning the 3rd language, he or she also learns structure of language, or gains a deeper understanding of what language is, what role language plays. And this can be done by bringing in concepts from Indian grammatical tradition. So unlike phrase structure grammar, which sort of gives you the patterns but doesn't connect so easily with the semantic structure of the sentence, here Indian grammatical tradition gives you representation. It has theories which are much more, much closer to the semantic structure. So therefore, this can help actually in language learning, or certainly it can help in gaining an understanding of different languages, or in this case 3 languages or 2 languages. And through this understanding, he or she gets a deeper understanding of knowledge structures. Because with internet coming in, I think our education is anyway already going through a transformation, and we are in this transition stage now. So access to knowledge will require understanding knowledge itself. What is the structure of knowledge, and where best to do it other than language. And if you do it through Indian grammatical tradition, it is also very natural and very intuitive at one level, much more intuitive than let's say the other grammatical traditions. So this can come very naturally in learning a new language, as well as in gaining an understanding of knowledge structures, which is what is needed when you go to internet and try to gain access. Hopefully this will also lead to better understanding, better writing style. So there is a need to express today. People are expressing themselves through internet medium, and this kind of teaching will also help in that. Okay, so I've sort of let me end now. I've reached the final slide. So first of all, the situation is very fertile. There is an acute need. Users are demanding content in their own languages. This is the time to step in. And Indian grammatical tradition, I believe, has a lot to give in terms of theories, in terms of understanding, and that can very directly go into technology. So there's a very natural synergy between Indian grammatical tradition and the technological capability that we are seeking to develop. Thank you. Okay, if there are questions.
Yes. Thank you, Professor Sangal. Each time I listen to you, I get some new insights. And today, when you presented the example of POF relation, part of relation, I could connect it to a Samartha Padavidhi. Maybe we can discuss this sometimes later. So now, are there any questions? Well, the question is.
So just a request.
Yeah.
So if you have a question, just raise your hand. We are not using the mics because they will not, Professor Sangal will not be able to listen. With the hand mic, he will be able to listen. Okay, so you can now speak your question. Okay.
My question is here, what is low resource language and how Hindi is a medium resource language?
Low resource means that the resources in digital form. I should have mentioned that digitally low resource. It doesn't mean otherwise low resource, but digitally low resource. So first thing would be amount of text that is available, because many of the machine learning processes require large text. So what is the amount of text that is actually available? Besides plain text, there may also be annotations. So you may do markup. Tree bank is an annotated resource. Okay, part of speech tags, chunk tags, marking of named entities, marking of technical terminology. So these are the resources that help in development of technology. And if a language has less of these, then you say it's a low resource language.
Any other question? Yes. Maybe you can introduce yourself so that Professor Sangal knows.
Hello sir, I am Pawan Kumar. So my question is that in your presentation in the penultimate slide you have mentioned that you can teach the concepts through Indian Grammatical Tradition, right? So there
Yes.
you have mentioned USR. What is that? You haven't mentioned that USR thing.
Okay. It's a name for whatever you have been seeing. Universal semantic representation,
Okay.
universal dependencies.
Okay.
But these universal dependencies are more semantic than what currently are called universal dependencies. They are very syntactic.
Okay.
So this is both syntactic and semantic in a way, I should add. So this is what you have seen. So through these, an understanding of Karaka relations, the grammatical structure, then how it relates with meaning and semantics. This is what I mean by universal semantic representation.
Okay. Another quick question. In that sentence, Ram ne Mohan ko khilona diya. There you have shown us the Karaka chart.
Yes.
There you have mentioned the K1, K2, K3, K4, that Karaka roles, right? So
Yes.
the K1 and K2, those are mandatory relations, and when it comes to this K4, which is a desirable thing, why is it so? I would like to know the reason. Why you have
This is, yes. So what is mandatory, what is optional, this comes from language. So languages realize this in their own way. So the language would say, no, you must provide this. So, karma must be there. Without that, the sentence would sound incomplete.
If that is the case, K4 should be there, right? Which is a mandatory thing, because the sutra says that karmana yama vipriti sasampradhanam, according to Panini,
Yes.
which means
So this is,
sampradhanam.
what people say that in Hindi this can be dropped and still it is acceptable. So as an action, yes, sampradhan should be there, time must also be there, space must also be there, adhikaran must also be there. But in realization of the sentence, what would you call as a good grammatical sentence?
Okay.
So this comes, therefore it becomes language specific. Okay, even though
Yeah.
the general idea is common, but it has to be taken, the specific language has to be taken into account.
Okay. Thank you, sir.
Any other question? Well, here you had mentioned about the WordNet. I would like to mention that Sanskrit WordNet is built, and Professor Malhar Kulkarni, who is here, he leads the development of Sanskrit WordNet.
Oh yes, now I remember, and I see Professor Malhar Kulkarni now. Earlier the camera, that in part of the image was cut. Yeah.
Yes. Any other question? Okay, sir, thank you very much for this talk. All
Thank
of
you.
us enjoyed it very much. Thank you.
My best wishes for the symposium. I could not unfortunately join. Yeah, good wishes.
Thanks
Thank you.
again, Professor Sangal, for your wonderful talk. So, although you are not here, we would still like to give you a souvenir on the behalf of the organizing committee through e-medium, and we will make sure that it comes to you.
Yeah, you can send it by email. Thank you. Thank you.
Four of our recent works, we're going to be doing a demo of them. Just to quickly put into perspective for about a minute, just see if this is working. No. 1 second. So our organization is called Sanskrit Research Institute. It's based in Oroville, near to Pondicherry, about 12 kilometers north of Pondicherry. And I'm a graduate research student with ANU, Australian National University. And the institute's part of Oroville. So it's an Indian institute. And I direct it, which is a lot of fun. And that's where we are. And this is our team. And team is international, on and off campus, voluntary, and interns, and some permanent like myself. I'm not going to go back on, I'm only going to focus on 4 of the newer works that we've done, but just to recap is that we've worked with educational tools and some research tools with Sanskrit. We did a dictionary, took a whole lot of, it's a meta dictionary, took data from many different sources. It was an aid for tertiary students and also secondary, like late secondary students. It's quite popular, and we keep modifying and improving it. It has its quirks, like anything, but it's getting there. And then we've done comparative grammars between Vedic and classical. It was really like just seeing the gap where things were missing, and then not to duplicate things that have already been done really well. And we've made some educational games, and we've done some things that have already been done before much better, so like Sandhi tools. And one thing that I quite like and it's used is we made a typing tool for touch typing Sanskrit. It uses its own system, but the idea was to basically use the neural maps you have in your brain without teaching something new. And it seems to be quite popular with people who haven't learned an existing system already. So I'm going to talk about some of our recent works, basically, that, and we've shared them already on Indology and with the scholarly community. And I'll dig in a bit of technical detail where needed, and obviously in the question time, you can hit me with the technical questions. So number one was I surveyed to see if there was a word frequency tool for Sanskrit, and I couldn't find anything that had been published and available. Oliver Helvig from the DCS had done elements, but he hadn't completed it. So we wrote some scripts in Python, and we extracted the snapshot of the DCS, which is in the public domain. That was 3.2 million words at the time, which was single-handedly done by one person. It's quite I think he deserves some kind of award if we have an award in the conference. Actually, it's up to 4-point-something million. So I don't know if he sleeps or not. So we extracted it, and then we took the data, and then we made different intuitive ways of looking at it. And this is the live demo. And so you'll see there's 3.2 million words with 67 unique words. What's defined as a word will basically be a stem and a prefix, a stem and a root for a verb, and oh, must I make it bigger? That's as big as my screen will get. Maybe I can go F11, that'll go one step bigger. That's about as, I can't do more than F11. Is it legible? Yeah, no. Well, I'll send you the slides, and I'm sorry about that. I think it's the DPI of the projector. So we try to, the objective here was basically to firstly accomplish the task of doing this, and we had to use data from somewhere, and DCS is the best data. It has limitations, but it gives you quite useful data for comparative frequencies. We've got a Ukrainian scholar now doing a comparison between frequencies in other languages with this data. And you can filter it down based on tagging that we tag the literature, the corpus that we use. So you could just say in Vedic, and it changes a lot. Things like Agni and Soma Marut will obviously come right up to the top of the pops in the Vedic, but they will lose after the late Vedic. They will start to be. And you can look at the Buddhist literature, and then things like Buddha will obviously come top of the pops. And yeah, there will be gray areas, of course. It's not, you can't be very specific, because a Buddhist era is not something you can measure with a piece of string, but you can generalize about the literature from that era. And you can also search it. If we reset you can search for a word if there's a word you have a fascination with, you can search for the frequency. And we've got some kind of graphing over time, but this is in beta, so I do not, you can see there's an error. So it is in beta, but it can be useful. And we put it out there, and it's being used. And then you can also filter by a specific text. Now, obviously, he hasn't done all the text. You'll see there's a star if the text is incomplete, and it's not starred if it's complete, because Oliver only did the things that were of interest to him. Now, at the end of my presentation, I'll talk about our Moonshot project, which is called Sanskrit Archive, and that will have a lot more than 3.2 million words. That's going to have hundreds of millions of words. So obviously, this will get more accurate, but 3.2 million is not a bad starting point. And it is on our cards to refresh it with the latest TCS data, but it's a lot of work. It's going to be like quite a lot of man-hours, so we haven't got around to doing it yet. But it's on the cards, in case you're wondering. And you can filter by author, by subject, and you can also filter by part of speech, POS, if you want, basically, based on how the data was tagged. So we just say noun. We don't go into the case, basically, at all. So yeah, it's out there, and you can play with it. Probably a few of you already know about it, and if you don't, please go and give us some feedback. And the second one we did, which was also a gap. Now, Oliver, once again, had already done this, but he had made a Windows desktop tool that couldn't operate in an automated way. Now, the bigger project that I'm working on needs an automated OCR engine. So initially, I tried to automate a Windows tool running through a script and sending data in and out, and it was just kludging it, clonking and kludging. It wasn't working, basically. Is it a kludge in programming when you don't get things to work? And so what we did is we worked with Tesseract, and with Google got a very nice API, and I collaborated with Ashok Popat, giving him a feedback loop on Sanskrit-specific errors in their engine. So I thought, rather let a company like Google throw lots of resources at solving this problem, because OCR, computer vision, is really complicated, and you need massive resources to do it very accurately. So it's got up to a level where I would say it's above human, it's close to human, close to a very high-level human accuracy. And it's definitely faster. And let's demonstrate it quickly. So what's nice about it is it works with the clipboard in the browser. So I'm just going to paste some, there was some Sanskrit in my clipboard. All right, there it is. So this is just a photograph or scan at quite a low DPI. And you can check it for errors. I'll reward anyone who finds an error. Okay, there might be an error there. Okay, it's pretty accurate, which everyone agrees. So this is browser-based. It's got Tesseract and the Google Vision API together, and then we're working with Google AI team to, if scholars report errors, we basically feed it back directly to Google, and then they improve it, hopefully. It's not always an instant fix like if it was Tesseract. Tesseract was originally pretty accurate, but much slower, because it uses a lot of resources to process. And now Google's just gotten so good. So this is being actively used by a lot of the digitization communities, and we're going to be upgrading it. I know that a lot of people wanted it to do documents. It's a mixture of two. It's Tesseract and Google running in parallel, basically. It runs on Node.js for those who want to get geeky about it. Okay, so this was the second recent project. We also announced it on Indology, and it's been relatively well engaged by the Sanskrit community. And it does IAST, and it does Devanagari. And it understands Sanskrit as a language, not just as a script, not just Devanagari as a script. So it understands context and edges and all the things it needs to. And keeps improving. This is the nice thing about using cloud technology, is you don't have to upgrade it. This was a reference in my 5th year at ANU. I was reading Panini. People thought I was a bit nuts, but it was fun. And it's really complex stuff. So I made like a programmer's reference because it's very programmatic. Should we keep the questions for after, or do you want to interrupt the discourse and then should we let it flow and then we just write your questions down and then I'll do them in reverse order, or first in, first out. Okay, so this is PERT, or Panini Research Tool. Now at the Bangkok conference there was that lovely Panini 2.0 and I was very inspired and I didn't want to duplicate what they did, so it's similar, it's got some overlap, but then what we did is I got permission from the copyright holders, from Vasu, basically. You'll see that this is the, so we've got, okay, so Valentine was there out of copyright. We digitized that. We've got a team of volunteers that are pretty good at doing sort of, well, we didn't digitize it, we just snippeted it into small bite-sized image. It hasn't been fully digitized yet. But where we could digitize, we did digitize. And then we took some from the Ashtadhyayi 2.0 project, that was a little bit. And then from Ramanath Sharma, we've also got permission to use his work, which is phenomenal work, for some of his work. And we had taken from many different sources. We also got audio recordings because the sounding of this literature was very important in the tradition. So I'm not sure if the audio is connected. Well, let's try that. But for what it's worth, you've got the full. Okay, speaker out. It's got a bit of feedback there. Oh, buzz. I don't think it's coming through the system. I think it's not connected. But you just have to believe me that it does chant quite well, everything. And it's just a consolidated reference with a search. Now, when you're studying Panini, the search is really, really useful. So you can search, ad infinitum, and then it understands to look through the translations and the definitions. And it was very useful for myself, and now I think a lot of other tertiary students are using it. If anyone has suggestions for improvements, I'm very, very open ears, and we were happy with this. This was also relatively recent work. And then the DLI, Digital Library of India, the reason we did this, it's okay, I think we'll skip the audio. It's totally fine, it's totally fine. I'll simulate it. The reason we did the DLI was the government site didn't go deeply into the documents. So once again, we worked with Cloud Vision. We threw everything onto the Google service, and then we've got a collaboration also with Google for storage. So it's 31 point something terabytes, which would cost a fortune normally to store. So we threw that onto the cloud, and then we just wrote some smart scripts that are using the Google Cloud Vision to understand this. And it allows you to do quite deep searches. Now, DLI is a very, very useful, and in our bigger project, there's a lot of info we're going to cross-reference to. I wanted to just have this, that it was available in an accessible way. So this is all, I'll do the demo for you in a second. It's a DLI mirror. Now, archive.org is partially done one, and then the government one is up and down, and then it's in transformation. So it's going through different evolutions, as far as I know. So it wasn't that reliable. It went through a long period of unreliability. So yeah, you don't even need to spell it correctly because it will intuit for the diacritics, and it should be quite fast. Now we're searching 31 terabytes of data in about 4 seconds, and probably it would be 2 seconds if I wasn't running through my mobile. And then, of course, you've got everything there, all the PDFs, and you can do what you want with them. And then we've got all the metadata and the bibliographical info. And this is also being used, I think some people use this and the government one and the archive. There's different advantages, but it was something that I wanted to have. It's got all of the, in theory, all of the out of copyright books that have been digitized. Not all, but a large percent. It's kind of like a mini Google Books of academia and institutions in India. And it's got some phenomenal, if you're looking for something really random, like a needle in a haystack. So with the cloud search, that needle in the haystack, that's the whole thing that the cloud search is good at. it's good at finding needles in a haystack. And so it was like a no-brainer to do this, and we did it. And once again, shared it with Indology, and people seem to be using it, which makes us happy. And then, okay. So this I actually presented in Bangkok. We're busy revising it now. It's our text-to-speech engine. And we're going to make it as an API that anyone can just call. We took Mary TTS, with a German AI Institute engine for text-to-speech, and then it works well for single words, and in theory for sentences. It can work. We just didn't focus on sentences because it was an individual word approach. I can't demo it, but it's working. You can all go on our dictionary sites and see it. So we're busy doing that as an API that will be a public API. It'll also be put on one of the cloud services, and then people can have audible Sanskrit wherever they want, and that can be useful, especially considering Sanskrit was not a written language until recent history. About 2,000 years it's only been written down. For the older history it wasn't written. So our moonshot we're working on, this is a collaboration with Wikimedia Foundation that we're beginning because it overlaps with some of their objectives, and they obviously have very deep pockets and great skills and abilities. And I met with their team in Cape Town. They had a Wikimedia conference. So we want to put the extant Sanskrit literature online. It's a moving target because as I speak this presentation, some literature has been decayed and destroyed somewhere. It's like global warming, like you talk about it, and we've already gotten warmer. So, but we're going to do it with two. Okay, so how much literature is there? Well, some people say, this was from Sheldon Pollock's estimate was 30 million manuscripts. That's a huge number, and it's his reference, not mine. Otherwise, it would sound like way too much. It's in language of the gods, if anyone wants to see it. So what's happened is Latin and Greek have had it done. You've got TLL and TLG, and they've done almost all the extant literature. And that's your classics, for European classics, and hasn't been done for Sanskrit. And I really appeal that we should all work together, and all these tools should make this happen. That in the next, say, decade or 5 years, we can have extant Sanskrit literature in digital form online. So I see it as quite an insolvable problem without two things. So it needs crowdsourcing. There's no way you can do it as an individual effort. Even if Oliver Helvig lived 1,000 years, it would not happen. And we've got to use neural networks, convolutional neural networks. So what we can do with the AI is we can do automatic breaking of the sandhi, and I think we can get up to 99%. We can do automatic parsing of the data and grammatical tagging and get to very high accuracy. We can do automatic sense disambiguation and also get very accurate, and we can definitely do translation. So with a convolutional neural network, as we have more data, it's going to get more accurate, and eventually it's going to be so accurate that you're not going to notice it anymore. So this is a moonshot. We're busy working on it. We've got some. It's a parallel work in operation. We should have something to present at the next. When's the next conference? In 3 years. So I should be able to present something at the next conference on that project. And that's my email. If anyone wants to reach me, we've got come to the end of the demo. Thank you very much.
Thanks, Martin, for this very wonderful demo. Questions for Martin?
Easy ones, please. Right.
Two questions. So, do you have any thoughts on providing an API for Google Vision OCR? So I have no experience setting up.
We can do that.
My Google Cloud account recently expired.
Yeah. I think we could do that. If you send an email, I think we could put it in the pipeline. Sure. There's no reason why we can't do that. It wouldn't be like a public. I mean, it would be free of charge, but it would be basically on an invitation basis. But yeah, we could do that for you. Sure. There's I see no technical reason why it's not feasible. But yeah, we just don't want the whole world doing it, because then the resources would get stretched. And Google's generosity to us would also be challenged. So we want to use it specifically for, so yeah, sure, we can do that. With pleasure. Oh yeah, sure.
When it comes to the CNN models that you're going to use for segmentation,
Yeah.
do you imagine using domain-specific, so models trained for a particular subprogram? To get to very high accuracy, then you're going to need to
Yes.
specialize.
Yes. We would model what's already been done successfully with languages like English. I mean, like English has got so much data. So Sanskrit is just another language. It's got nuances like Sandhi that English doesn't have. But we would use whatever, it's a moving, because it's constantly improving with Moore's law and so much research happening with AI. There was just a publication of DeepMind basically doing the Greek manuscripts with missing letters where there was total, much more accurate than humans now. So I think with crowdsourcing and AI, our archive project, it's the only way to achieve it. There's no other way. Like Elon Musk said, like, do you want to get to Mars, you've got to have reusable rockets. There's no other way. So it's the same. Like, for me, because my background is from computer science to Sanskrit, I can't see any other way to easily solve that problem. And I do see it as a solvable problem, just a difficult problem. It's difficult because the data's got a high noise to signal ratio. There's a lot of, you know, a lot of issues with data. And then also, well, there's a limited pool of scholars who can give a high quality curating of and tagging. And, you know, you can get a lot of people who say they know Sanskrit, but to the level that you want to do it, on say, Oliver's level of tagging, but we've got a way of incentivizing people. That's in the pipeline for the project. So let's see how it goes. Sure. Any more questions?
Do you have any estimate of the annotated data that you need for the tag data or data to the past?
I mean, well, how much more data do we need to do it? I think maybe 10 times more than is currently available. No, you're talking about for parsing. Maybe, yeah, the more data you have, the better. So I don't know. I can't estimate until we've started that project. But the more data, the better. I don't know. Maybe you could guess.
What about the segmentations?
Yes.
How much data do you need for the
I don't know, actually, at the moment. I don't know.
the data that is available with or
No, the DCS data is like 3.2 million words.
So if you use all that data,
Yeah.
is it possible?
It's possible to build a rudimentary system that is maybe 80% accurate.
80%.
I think so, yes.
So,
That's my estimate.
and if we use the 80-22, then you need another.
No, but we're going to have a lot of data. That's the whole idea is to have the data.
If I have whole Sanskrit corpus annotated, then I can give them expression calculation.
Yes.
I can do. No, try to understand what I'm saying.
Yeah.
If the whole Sanskrit corpus, 1,000 times whatever it is.
Yeah. 30 million
If
manuscripts.
everything is manually tagged, then you can
No, it's
create
not.
a machine learning system.
No, it's not going to be manually tagged. It's going to be assisted tag. That means humans will be involved, but the tools will speed up the process, basically. Just like Wikipedia.
How much is needed for bootstrapping?
I don't know at the moment how much data, because we haven't done that part of the project. We're doing the formative phase. That will, I mean, I can tell you for like the frequency, the data is useful, but I can't speak about unknowns that we haven't done it yet. It's just hypothetical. Maybe Oliver Helbig could give a more accurate estimate, because he's the best with that. But I mean, so maybe if you have like the DCS, it's a very good starting point, basically. But it's not tagged to the detail that we're going to have our data tagged to. Like Peter Schaaf's tagging is much more detailed. Oliver's tagging is just suited for his particular need with DCS, basically. No, so I think the Sanskrit library was more detailed, like the samasas were what type of compound, and then Oliver doesn't care about what type, he just says compound. He doesn't say what type of compound. So Peter Schaaf goes into it's like the gold standard. So I would use a standard like that for the tagging, because that level of detail is very useful linguistically to understand meaning and context. The type of compound can make or break the meaning, you know, in the Vedic or the classical? I'm sorry about the questions I can't answer about the amount of data because yeah, sure. But it's possible. Do you think? Yeah. Okay. Next question.
Any more questions? Okay, so let's thank again
Thank you.
Martin.